Mr. Walber here. 10.4 is compound events. A set of all possible events is what's called a sample space, and that's what we're going to be looking at. Multiple different events occurring and finding the probability of those. To find the probability, we can either draw a tree diagram or use what's called the counting principle. I'll show you how to use both of those here. Counting principle is multiplying the possible outcomes of one event by the possible outcomes of the other event. So basically just multiplying the two things together. Tree diagrams, what I'll do next, and let's go to that. Here's an example. You randomly choose a crust and a style of pizza. Find the sample space, how many different pieces are possible. You draw what's called a tree diagram. If I say I have thin crust and I have stuffed crust, those are two possible things you can choose. Once you choose one of these, you then can either pick Hawaiian, I'll just put an H for that, Mexican, pepperoni, or veggie. So, when we take a look at this of our possibilities, we could have thin crust with Hawaiian, thin crust with, Mexican, thin crust with pepperoni, thin crust with veggie. Stuffed obviously needs all of those as well. Hawaiian, Mexican, pepperoni, and veggie. So, how many possible different pizzas could you choose? Well, you do have to include these. Understand, thin. So my possible thin crusts are 1, 2, 3, 4. Possible stuffed crusts are 1, 2, 3, 4. So for a total of 8 possible choices for pizza. So there is how to do it by drawing a tree diagram. Let's look at counting principle. It says find the number of possible outcomes of rolling a number cube and flipping a coin. Well, let's start with the flipping the coin, because that's the easiest one, because we know we can either have heads or tails. Now, after we flip either heads or tails, we can we're going to roll a number cube, and obviously our possibilities are 1 through 6 here. Whoops, I should do 5 as well. Sorry about that. 1 through 3, 4, 5, 6. Obviously, tails, same thing. Obviously, this is another tree diagram, but I wanted to show you an easier way to do this, and that's to use what's called counting principle. Counting principle, we said, was to multiply the possible outcomes times the possible outcome of the second thing. Well, I have 2 possible outcomes of heads or tails. For the number cube, I have 6 possible outcomes. So basically, if I multiply 6 times the 2 different choices for the coin, 6 times 2 gets me 12, and sure enough, if I add all of these together, I had 6 total possibles here and 6 total possibles here for a total of 12. So counting principle says to multiply the 2 possibilities together. Heads and tails, so I have 2 here and I have 6 here, so 6 times 2 gets me 12 as my possible outcomes here. So this time I'm not going to draw the tree diagram at all. I'm just going to go ahead and just do counting principles. So how many different outfits can you make from the t-shirts, jeans, and shoes in the closet? Well, I have 3 pairs of shoes, so I'm going to multiply 3 times. Shirts, I have 1, 2, 3, 4, 5, 6, 7. So I'm going to multiply that by 7. And then it looks like I have 4 pairs of jeans at the top, so I'm going to multiply that by 4. I am going to go ahead and multiply. 3 times 4 is 12. 12 times 7, that gets me 84. So there are a total of 84 possibilities of combinations you could wear there between the jeans, the shirts, and the shoes. Again, that's counting principle by multiplying the different possibilities together. Alright, let's take this a step farther. It says in example 2, what's the probability of rolling a number greater than 4 and flipping tails? Well, we're talking probability now. Obviously still using counting principle and tree diagrams here, but we're going to take a step farther and try to look at probability. Example 2, by the way, was when we flipped a coin and we rolled a number cube. We want to roll a number greater than 4. Well, 1, 2, 3, 4, 5, 6 are our possibilities. If I roll a 1, I then can get heads or tails. I roll a 2, I can get either heads or tails. I roll a 3, I can get either heads or tails. I think you get the idea of what I'm doing here. You're going to need to do a tree diagram when it comes to stuff like this because you're trying to find probability, and counting principle is not going to be enough for you here. Obviously, I still have 12 possibilities, so it's out of 12. But we have to think about, we want to roll a number greater than 4, so it's got to be a 5 or a 6, and we want to flip tails. So there's only 2 possibilities here. I could roll a 5 and flip tails, and I could roll a 6 and flip tails. So I only have a two chances there. How many is it out of? Well, we're still looking at all of these, so it's still out of 12. So it'd be 2 out of 12, or when I reduce that, it would be a probability of 1 out of 6. Just another example, looking at compound events. Obviously took a step farther with probability. We'll look at more of these tomorrow, look at more tree diagrams, look at more counting principle, but hope you followed along some of that, and we'll keep practicing. Have a good night.